On the screen before you, you see an example of how to take a function in factored form and turn it into a quadratic function in standard form. We started with the factored form x minus 5 times x plus 2. We then used the area model to multiply x minus 5 and x plus 2. We combined like terms to end up with the quadratic function f of x equals x squared minus 3x minus 10 in standard form. I'm now going to show you how to do this process in reverse, to go from standard form back to factored form. And the process is going to be pretty similar, and it's also going to involve using the area model. Consider the function f of x equals x squared minus 7x plus 12, which is a quadratic function in standard form. We want to factor it, which means turn it into a quadratic function in factored form. Down below, you see I've set up my parentheses, because in my head, I know that I want two expressions, each of which to have two terms, x minus something or x plus something. How are we going to do this? Well, we're going to go to a similar process as before. We're going to use the area model to help us factor. But this time, instead of filling out the outside first and then using that to figure out what's inside, we're going to fill out the inside first and then use that to figure out what's on the outside. We know x squared can go here. We know 12 can go here. And we know we need to break up negative 7x in some way, shape, or form and put that in the remaining two empty boxes. How do we break up negative 7x? Let's hold on to that question for 1 second. Let's see if we can start to fill out the outside. Well, we know an x and an x need to go there because x times x is x squared. And we know some number goes here. That some number, when multiplied by x, will give us something x. And we know some other number goes here. That number, when multiplied by x, will give us something x. We also know that something x plus something x is going to equal negative 7x. So to recap, we need a red and a green number that when added together produces negative 7, and when multiplied together gives us 12. Does this sound familiar? Hopefully, it reminds you of the X game. We need two numbers that are going to multiply to 12 and sum to negative 7. What are those two numbers? Take a few seconds to think about what they may be. That's right. They're negative 3 and negative 4. Negative 3x plus negative 4x gives us negative 7, and so now we can complete the interior of our area model with negative 4x and negative 3x. Once the interior is complete, we can complete the exterior of the area model. X times what gives you negative 4x? Well, that's negative 4. And x times what gives you negative 3x? Well, that's negative 3. As one sanity check, we can confirm that negative 3 times negative 4 produces 12. Now, on the exterior of the area model, we have our two factors. So we can write those to create our factored form of this quadratic function, x minus 3 times x minus 4.